Solving quadratic equations by completing the square. This is the fourth of our 5 different methods for solving quadratics. Let's begin by doing a warm-up. Factor the following trinomials. So I've got trinomials, 3 terms. When we factor, we first always look for a greatest common factor, and in fact, none of these 4 have a greatest common factor. My leading coefficient is always 1. So I'm thinking about what do I multiply together to get 16 and adds to 8. That would be positive 4 and positive 4. So typically some of you wrote your answers as x plus 4 times x plus 4. But to make it easier, we could also write the quantity x plus 4 squared. So that's the way we're going to write them for these next 3. X squared minus 18x plus 81. What do we multiply together to get positive 81? That adds to negative 18. That would be negative 9 and negative 9. So I would have the quantity x minus 9 squared. Work through the next 2. This one would be the quantity x plus 1 squared. And the last one would be the quantity x minus 5 squared. All 4 of these trinomials are what we call perfect square trinomials. If you have a perfect square trinomial, you can solve the quadratic equation by square roots. Okay, so let's talk about square roots that we did in our earlier video. Directions say, factor the perfect square trinomial, then solve the equation by square roots. Remember, a positive number always has 2 square roots, so you must solve for both cases. So in this first set, each of these 4 problems, the trinomial that we have on the left is a perfect square trinomial. It's going to be similar to these top 4. So as I look at number 1, x squared plus 4x plus 4. We're ignoring the 25 for right now. I want to factor the left side, and that is a perfect square trinomial would give me the quantity x plus 2 squared equals 25. Now let's think about how we did the square root method. Okay, step number 1 in the square root method was to isolate the x squared. Well, that's what I have here. I've isolated something squared. So when I do inverse operations, at this point, I want to get rid of the squared. So I square root both sides, making sure to remember the positive and the negative. So on the left-hand side, the square root and the squared cancel each other out. So I'm left with x plus 2 equals positive and negative. The square root of 25 is 5. My x is not yet by itself. So to get the x by itself, we're continuing with inverse operations. So we would subtract 2. How I'm going to write this is negative 2 plus or minus 5. So let's think about how those solutions will be written. Negative 2 plus 5 is 3, and negative 2 minus 5 is negative 7. Select pause and try just number 2, then come back to check. Hopefully for number 2, you came up with the solutions of positive 15 and negative 3. Select pause, work through 3 and 4, then come back to check. Your solutions for number 3 are x equals 9 and 5. The solutions for number 4 are x equals negative 2 and negative 4. These 4 examples that we did up above all had perfect squares on the left-hand side of the equal sign. Unfortunately, that isn't always the case. So when you do not have a perfect square trinomial, you can create one. This process is called completing the square. So if you don't have one, you can make one. Follow the steps below to solve the equation by completing the square. Step number 1, rewrite so that the constant is by itself on the right-hand side. So I'm going to subtract 7 from both sides. So I'm left with x squared plus 8x, leave a space for me, equals -7. Now, on the left-hand side, I need to finish my trinomial. I want to make that a perfect square trinomial, so I got to figure out what number might I put there to make it a perfect square. Well, step number 2 tells us you are going to take half of your b value. Our b value is +8. So half of +8 is 2. No, it's not. Half of +8 is 4. Then you're going to square it. 4 squared is 16. That's what you are going to add to both sides. So we're going to fill in up here plus 16 on both sides. Because it is an equation, it must remain equal. So what you do to one side, you have to do to the other. Now step 3, factor the perfect square trinomial. So just like we did in the 4 examples up above, factor that trinomial. X squared plus 8x plus 16 would be factored as the quantity x plus 4 squared. And then let's simplify the right-hand side. -7 plus 16 is 9. The quantity squared is isolated. So let's square root both sides, making sure to remember the positive and the negative. So on the left side, I'm left with x plus 4 equals positive and negative. Square root of 9 is 3. I've got to get x by itself. So let's subtract 4 from both sides. So I have x equals -4 plus or minus 3. So my solutions, -4 plus 3 is -1, and -4 minus 3 is -7. Let's look at the next page. We've got 4 examples to take a look at here. The directions say find the solutions of the following quadratic equations by completing the square. So we're going to follow that 4-step process because as I look at the left here, x squared minus 12x plus 11, that's not a perfect square. Okay, there's nothing I can do here to multiply to get the 11. You know, it's not a perfect square. Okay. So what we do is bring over the 11 to the other side. Remember, as you write it, leave a space. So x squared minus 12x equals -11. Now I got to figure out what number goes in there to complete my perfect square. We take half of our b value. My b value is -12, so half of -12 is -6, and then I square that to get 36. So I'm going to add 36 to both sides. My next step is to factor my perfect square trinomial. What do I multiply together to get positive 36 that adds to negative 12? That would be negative 6 and negative 6. So my factoring would be the quantity x minus 6 squared equals, and then let's simplify what's on the right. Negative 11 plus 36 is 25. Let's inverse operations to get rid of our squared. So let's square root both sides, making sure to remember the positive and the negative. That gives me x minus 6 equals positive and negative 5. Get the x by itself by adding 6 to both sides. So 6 plus or minus 5. So 6 plus 5 is 11, and 6 minus 5 is 1. Select pause and work through question 2. Just question 2, then come back to check. Our solutions to number 2 are x equals 2 and negative 6. Number 3 is a little bit different, so I'm going to work through that one with you. Step number 1 is to bring the constant over to the right-hand side. So let's add 4 to both sides. Leave a space there. Now I got to figure out what I add to both sides to make it a perfect square. So I do half of negative 2, which is negative 1. Square that and get 1. So I'm just going to add 1 to both sides. When I factor my trinomial on the left, I have x minus 1 squared equals 4 plus 1 is 5. Now let's get rid of our squared by square rooting both sides. Don't forget the plus or minus. That leaves me with x minus 1 equals plus or minus. The square root of 5 is not an integer, so I'm going to leave it as an exact answer, the square root of 5. Last step, get your x by itself. Add 1 to both sides. So the way I'm going to write my answer is 1 plus or minus the square root of 5. Select pause and work through number 4. I hope that you also got the answer x equals negative 3 plus or minus the square root of 19.